What if the ground beneath California just sent a warning? Not a sound, not a crack, not a quake you could feel. Just movement. Silent. Measured. Real. Overnight, deep beneath one of the most closely watched fault systems on Earth. Instruments detected something unusual. Subtle shifts, micro-tremors, a quiet signal from miles underground. Scientists are paying attention because when the Earth whispers, it's usually worth listening. And right now, geologists are asking one question. Is this routine tectonic motion not or the early sign of pressure building below the surface? Stay with me. Because what they're seeing matters. California isn't just famous for beaches, tech, and sunshine. It sits on the edge of two massive tectonic plates, the Pacific Plate and the North American Plate. Where they meet, friction rules. And that boundary has a name you've heard before, the San Andreas Fault. It stretches roughly 800 miles through California, a massive fracture. In the Earth's crust where two plates grind past each other horizontally. Not collide, not separate, slide, but they don't slide smoothly. They stick, pressure builds, and when the pressure finally releases, the ground shakes. That's why scientists monitor this fault constantly. Sensors, satellites, strain meters, seismic arrays. Because unlike storms or floods, earthquakes rarely announce themselves clearly. The only hints come from subtle changes deep underground. And recently, those hints increased. Over the past monitoring period, instruments along sections of California's fault network recorded unusual seismic patterns. Not large earthquakes, not destructive shaking, but something quieter. Today, researchers observed increased micro-tremor activity, slight but measurable ground displacement, small clusters of low-magnitude seismic signals. These signals are so faint that humans can't feel them, but machines can. And machines don't guess, they measure. Some sensors registered tiny pulses of motion repeating in irregular bursts. Others detected millimeter-level shifts along sections of crust that normally remained still for months. To the public, this means nothing. To geophysicists, it means something changed, not necessarily danger, but definitely activity. When seismic data shifts, scientists don't panic. They analyze. Teams from geological monitoring agencies began reviewing waveform patterns, timing intervals, and depth signatures. Their conclusion so far, there is no confirmed indication of an imminent major earthquake. Let's repeat that clearly. No immediate disaster has been forecast, but experts are watching closely. Why? Because subtle motion can sometimes indicate stress redistribution inside a fault system. Think of it like pressure shifting inside a sealed structure. One section relaxes, another tightens. Geologists describe it as fault creep or stress transfer, natural processes that happen regularly. Still, when patterns change suddenly, researchers pay attention, not out of fear, out of responsibility. Because the goal of seismic science is not prediction, it's understanding. To understand why these small movements matter, you have to picture what's happening miles underground. Imagine two enormous slabs of rock pressing against each other with the force of continents. They want to move, but friction locks them in place. Over time, stress builds along the fault line like tension in a stretched rubber band. Most of the time, nothing happens. Until suddenly, release. That release is what people call the big one. Scientifically, that phrase doesn't mean a specific earthquake. It refers to a large magnitude rupture along a major fault capable of producing widespread shaking and structural damage. Important point. Big earthquakes don't happen because of one small tremor. They happen because of decades, sometimes centuries, of accumulated stress. The small signals scientists detected recently could simply be part of the Earth's natural pressure balancing process. In fact, many micro-movements actually reduce stress instead of increasing it. That's why interpretation takes time. Data must be studied carefully before any conclusion is made. So here's the question researchers are quietly investigating right now. Is this just routine tectonic adjustment or something building beneath the surface? No one is claiming danger, but no serious scientist ignores new data either. Because history has shown something important about earthquakes, they don't always give clear warnings, and when they do, those warnings are often subtle. California's geological record is filled with reminders of how unpredictable seismic activity can be. Some major earthquakes struck with no obvious precursors. Others were preceded by small tremors, minor ground shifts, or unusual strain readings. There is no universal pattern. That's what makes earthquake science so challenging. For example, some large quakes occur after long, quiet periods. Others happen in areas that showed little activity, and sometimes clusters of small tremors lead to nothing at all. This uncertainty is why experts never claim they can predict earthquakes precisely. They can estimate probabilities, they can analyze risk, but they cannot set a date. What they can do is monitor every vibration the Earth produces, and look for patterns that repeat over time. That's exactly what they're doing now. Modern seismic monitoring is far more advanced than it was decades ago. Today, California is covered by a dense network of instruments designed to detect motion smaller than the width of a human hair. These systems include seismometers, measuring ground vibration, GPS stations tracking crust movement, satellite radar analyzing surface deformation, borehole sensors measuring underground strain. Together, they create a real-time map of how the Earth's crust is behaving. Some systems can even send early warnings seconds before shaking reaches cities. That might not sound like much time, but a few seconds can be enough to stop trains, shut down gas lines, pause surgeries, alert schools. Early warning doesn't prevent earthquakes, it reduces harm, and every new data signal helps improve those systems. Right now, researchers are focused on 3 key indicators. 1. Frequency. Are the micro-tremors increasing? 2. Location. Are they clustering along a specific fault segment? 3. Depth. Are they occurring deep underground or closer to the surface? Each factor tells a different story about what's happening inside the crust. If activity stays low and scattered, it likely means routine tectonic motion. If patterns intensify or migrate, scientists study them more closely. This is not guesswork, it's pattern analysis. And pattern analysis takes time, which means answers don't come overnight. Here's something many people don't know. The Earth is always moving, even when you feel nothing, even when everything seems still. Every day, tectonic plates shift slightly, stress redistributes, tiny fractures form and seal, pressure accumulates and releases. Most of this activity never leads to a noticeable earthquake. In fact, thousands of micro-tremors happen every year that no human ever feels. They're part of the planet's normal behavior. So when scientists detect new motion, it doesn't automatically mean danger. It means information. And information is how science protects people. Short answer, nope. Concerned awareness is different from fear. Experts are not issuing warnings of a major earthquake. They are not telling residents to evacuate. They are not predicting catastrophe. What they are doing is monitoring the situation carefully, because that's their job. And that's what responsible science looks like. Calm, careful, evidence-based. Living in California means living with earthquake risk. But risk doesn't mean helplessness. Preparedness dramatically reduces danger. If you live in an earthquake-prone area, experts recommend simple steps. Keep an emergency kit with water, food, flashlight, batteries, secure heavy furniture to walls, no safe spots inside your home. Meow. Have a family communication plan. Practice drop cover hold drills. These actions don't require fear. They require awareness. Prepared people react faster. And faster reactions save lives. Many people think earthquakes strike without any scientific understanding. That's not true. Scientists understand earthquakes very well. What they cannot do yet is predict the exact moment one will occur. It's like knowing a storm will eventually form somewhere in the ocean, but not knowing precisely when or where lightning will strike. Research is ongoing worldwide to improve forecasting methods using AI analysis, deep earth imaging, and advanced sensor networks. Every new signal recorded today helps improve tomorrow's knowledge. So even subtle movement matters because it adds data to humanity's growing understanding of how our planet works. Right now, instruments continue recording. Scientists continue analyzing, and the fault continues moving slowly, silently, deep below the surface. Maybe the recent signals fade away and nothing follows. Maybe they're just routine tectonic adjustments. Or maybe they're part of a larger pattern that will only become clear weeks or months from now. No one knows yet, and anyone who claims they do isn't following the science. The Earth doesn't send messages and words, it sends movement, tiny shifts, silent tremors, microscopic signals hidden beneath miles of rock. Most of the time, those signals mean nothing dramatic. Sometimes they mean something important. Right now, scientists are listening carefully, not because disaster is coming, but because knowledge is power. And understanding the ground beneath your feet is one of the most important sciences on Earth. Stay informed. Stay prepared, not afraid, because awareness is stronger than panic.